Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. Remember the program is still Manifested Online Classes. In our previous lesson, we discussed the reaction between alkali metals and oxygen. And we said that alkali metals react with oxygen, leading to formation of oxides. That is, when sodium reacts with oxygen, it leads to formation of sodium oxide. But when sodium reacts with little amount of oxygen or limited amount of oxygen, it leads to formation of sodium oxide. But when it reacts with excess amount of oxygen, it leads to formation of sodium peroxide. When potassium reacts with oxygen, it leads to formation of potassium oxide. That is what we learned in the previous lesson. And I left you with the assignment of writing balanced chemical equations when potassium and oxygen reacts and when sodium and oxygen reacts. I hope you've done that. In this lesson, we are going to discuss the reaction between alkali metals and water. Therefore, alkali metals alkali metals are three. We have lithium, sodium, and potassium. I want us to start with the first one, which is lithium, and see how lithium reacts with water. When you place lithium in a trough of water, then lithium floats on the surface of water. Lithium floats on the surface of water. And also, a colorless gas is produced. A colorless gas is produced, and this colorless gas being produced is hydrogen gas. So hydrogen gas is produced. Hydrogen gas is colorless, and that is a gas which is produced when lithium reacts with water. Then the gas does not ignite spontaneously. The gas does not ignite spontaneously. And lastly, the resulting solution turns red litmus paper blue, showing that the solution is alkaline. So an alkaline solution, when you place a litmus paper or a red litmus paper into an alkaline solution, then this red litmus paper turns blue. So therefore, this is what you expect to see when you place a piece of lithium metal in water. First, it floats on the surface of water. And the reason why it floats on the surface of water, it is because it has a lower density. So the density of lithium and the density of water compared, so the density of lithium is lower than the density of water, and that's why it does not sink, it floats on the surface. Then the reaction between lithium and water leads to formation of lithium hydroxide solution, and hydrogen gas is produced. And the hydrogen gas produced is the one we are calling a colorless gas, which is being produced. Then this gas does not ignite spontaneously, does not ignite all of a sudden, it does not. And the resulting solution is now alkaline. Then if you were to write the equation for the reaction, then it will be lithium reacting with water, leading to formation of lithium hydroxide and hydrogen gas. Hydrogen gas is produced. Then again, if we were to balance the equation for the reaction, then we balance, we did a 2 there and another 2. Then again, we need another 2 so that we can be able to balance the number of hydrogen atoms on both sides. Therefore, the equation is balanced. This is what we are calling an alkaline solution. Lithium hydroxide is alkaline, and therefore it turns a red litmus paper blue. That is what happens when lithium reacts with water. And this is the equation to show the reaction between lithium and water. Next, I want us to see what happens when sodium reacts with water. First, when you place a piece of sodium in water, remember again, you see that you cut a very small piece because these metals are very reactive. And therefore, you should work always, or you should always work with small amounts. When you place sodium in water, see that it darts on the surface of water. That is just to move very fast on the surface of water. So when you put a piece of sodium on the surface of water, then it just darts very fast on the surface of water. Then it also melts into a silvery ball. It melts into a silvery ball. Third, a hissing sound is produced. So a hissing sound is produced. I believe you know the hissing sound. That's how it is produced as a result of sodium reacting with water. Then a colorless gas is produced. And lastly, the resulting solution turns red litmus paper blue. Turns red litmus paper to blue. Therefore, this is what we have said, that the solution is alkaline. The solution is alkaline, and therefore the red litmus paper is expected to turn from red to blue. Maybe going back a little bit, we've seen that the sodium, it darts on the surface of water. The reason why, again, it's darting on the surface of water, it is because it has a lower density. It has a lower density. So the density of sodium compared to the density of water, the density of sodium is lower, and that's why it is moving on the surface of water. Again, it melts into a silvery ball. The reason why it is melting into a silvery ball, it is because the reaction between sodium and water is exothermic. And being exothermic means that the reaction leads to production of heat. So the heat produced by this reaction is now what is melting this small piece of sodium metal into this ball. So it melts because the reaction is exothermic. the reaction is exothermic, the reaction which is leading to production of heat to the surrounding. Then the hissing sound is due to production of hydrogen gas. So due to production of hydrogen gas. So due to production of hydrogen gas. So that is why we have the hissing sound. And again, I need to add that this hydrogen gas can ignite spontaneously. The hydrogen gas produced so it can ignite spontaneously again because the reaction is exothermic, and the reaction being exothermic, then that amount of heat which is being produced can light up hydrogen, because again, you remember in Form 1 we said that hydrogen is highly explosive, and again it should not be allowed to go to the atmosphere because it can easily explode. So the hydrogen gas produced can easily ignite. Then lastly, the resulting solution turns red litmus paper blue, then showing that the reaction is exothermic. And therefore, the equation for the reaction will be sodium, which is a solid, reacts with water, which is a liquid, leading to formation of sodium hydroxide, a solution, or what you call aqueous, and hydrogen gas is produced. Therefore, to balance the equation, if we need a 2 before sodium, the 2 before sodium hydroxide to balance the sodium atoms, and a 2 just before water to balance the hydrogen and oxygen atoms. Therefore, that should be the equation for the reaction. And this is what we have called an alkaline solution. That is the solution which is making the litmus paper turn from red to blue. Then the last element is potassium. Then what happens to potassium? So when you place potassium, a piece of potassium in water, then this potassium, it also darts on the surface of water. So potassium also darts on the surface of water. It also melts into a silvery ball. It melts into a silvery ball again because the reaction is exothermic. Then the resulting solution turns red litmus paper to blue. The resulting solution turns red litmus paper to blue, and therefore, again, shows the solution is alkaline, and the hydrogen gas produced ignites spontaneously. Because the reaction is exothermic, and hence this gas reacts very fast. Then potassium vapor burns with a purple flame. potassium vapor burns with a purple flame. And therefore, the hydrogen gas produced, because the reaction is very much exothermic, it leads to production of a lot of heat, then this potassium will burn, leading to production leading to production of, or burns with a purple flame. Then the reaction is violent. The reaction between potassium and water is violent. The reaction between lithium and water, this reaction is vigorous. So it is just vigorous. And the reaction between sodium and water is just more vigorous. And all of them leads to production of alkaline solution. So if you look at the reactivity, again, all of them, the lithium is, the reaction is vigorous. Sodium, the reaction is more vigorous, so it means that it is more reactive than lithium. And this one is violent, meaning that it reacts very, very fast. Then maybe if we include the equation for the reaction between potassium and water, say potassium, which is a solid, reacts with water, leading to formation of potassium hydroxide and hydrogen gas. Therefore, to balance, again, you need an equation which is balanced, and we balance it like that. And this solution, which is now potassium hydroxide, is the alkaline solution. So potassium hydroxide is also alkaline. So that is how alkali metals react with water. Maybe to go through what we have discussed, we have seen that lithium, when you place a small piece of lithium metal in water, then this piece of lithium floats on the surface of water because it has a lower density. There's also a colorless gas being produced, and this colorless gas is hydrogen, because when an alkali metal reacts with water, it leads to formation of a metal hydroxide and hydrogen gas. Then this gas does not ignite spontaneously. Then the resulting solution is alkaline, because it is turning red litmus paper to blue, and that is a characteristic of an alkaline substance. Then you have written the equation for the reaction. Then ensure again, anytime you write the equation, then a correct equation should have correct chemical symbols. Therefore, symbols should be correct. Second, the equation should be balanced. And third, the physical states should be included. Then lastly, the reaction is vigorous. So it's a bit vigorous. Second, sodium, we have seen that it does on the surface of water because, again, it has a lower density. Then it melts into a silvery ball because we have seen that this reaction is exothermic. An exothermic reaction leads to production of heat to the surrounding, and that heat is now the one which is melting the piece of sodium metal. A hissing sound is produced, and this hissing sound is due to production of hydrogen gas. The hissing sound or the colorless gas is hydrogen. Then the resulting solution is alkaline because it turns the red litmus paper to blue. Then hydrogen gas produced can ignite spontaneously because the reaction again is exothermic, and therefore it can burn. Then the equation between sodium and water, again, when sodium reacts with water, then sodium hydroxide is produced and hydrogen gas. So the resulting solution you are talking about is the sodium hydroxide. It is alkaline. When you place the red litmus paper in this solution, the red litmus paper will change the color from red to red to blue. Then the reaction is more vigorous compared to lithium. Then lastly, we have potassium. Then potassium darts on the surface of water. When you place it, it does not sink, it does on the surface, again to show it has a lower density. It melts into a silvery ball because again the reaction is exothermic, just like in sodium. The resulting solution turns red litmus paper to blue, again to show it is an alkaline solution. Then the hydrogen gas produced ignites spontaneously because the reaction is highly explosive. The reaction produces a lot of heat, so the reaction is exothermic, and that heat can burn the hydrogen gas produced, leading to burning with a purple flame. Then the reaction is this: potassium reacts with water, leading to formation of an alkaline solution of potassium hydroxide and hydrogen gas. Therefore, you need to understand that. Just know what is happening. If somebody asks you what happens, or state 4 observations which you will be able to make when you drop a piece of sodium metal in water, then I know right now you can be able to do that because we have gone through that. So ensure you also go through it on your own and see whether you understand it. Then I will leave you with this assignment. And the assignment is to write balanced chemical equation of the reaction between water, lithium, sodium, and potassium. Therefore, I expect a balanced chemical equation of lithium reacting with water, sodium reacting with water, and potassium reacting with water. Ensure that you have done that before we meet in the next lesson. In the next lesson, we will be discussing the reaction of alkali metals with choline. Thank you for being part of this lesson. Meet you in the next lesson. Bye.